Hi students, nice to see you. Let's go over Illustrative Mathematics Unit 8.1.3, Lesson Grid Moves. Hopefully by the end of this lesson you feel comfortable seeing translations on grids. First, look at this strange graph. What do you notice and what do you wonder about this graph? It's called an isometric graph. The first thing you might notice is that there are triangles instead of boxes. The second thing you might notice is that there are parallel lines running diagonally in this direction, as well as in the other direction. There are also vertical lines running parallel. It's hard for me to draw straight with my mouse. There are no horizontal lines, and there are no 90-degree angles. You'll also notice that there are triangles, and where the lines intersect is called a vertex. I want to type that for you. A vertex. That's what it's called where lines intersect. And these vertices have 6 lines intersecting in one place. You can see the lines 1, 2, 3, 4, 5, 6. Each little triangle is an equilateral triangle. I'm trying to talk as I draw with my mouse. An equilateral triangle has sides of equal length. Do you know the angle of each equilateral triangle? The angles are the same. There are 3 equal angles. How could you figure out what that angle is? Well, here's how I look at it. I draw a circle because I know that a circle has 360 degrees. I want to draw that for you. A circle has 360 degrees. So if a circle has 360 degrees and there are 6 triangles in the middle of the circle, then what is the angle of each triangle? Well, it must be 360 degrees divided by 6, and that equals 60 degrees. So each triangle point is a 60-degree angle. Let me see if I can draw a large 60-degree angle for you to see. If I look at this vertex here, and I'll try to draw with my finger, there's one line and there's the other. That is a 60-degree angle. Okay. Now here on this line, it says type in your answer. So this is your chance to show me what you notice about this isometric graph and what you wonder, like why would we use this? Why are there no 90-degree angles? Whatever you're thinking. Okay, please look at the next part here. Follow the directions below each statement to move the figure. Use vectors to show translations. A vector is a quantity that has a magnitude and direction. It is usually represented by an arrow. Okay, I'm going to put number 1 here. They didn't put numbers on this, but I think it needs it. So this is number 1. And if you scroll down, it says here, choose the next question. Look what happens when you change this. Number 1 has A prime. Number 2 has C prime. Number 3 has point O. And number 4 has a line. Okay, now that's why I labeled this as number 1, because number 1 uses A prime. Number 2 uses C prime. Number 3 uses the center O, and number 4 is going to use this line L. So please remember that, and we're going to go back up to number 1. And then for number 1, I need to click the slider to question number 1, and that's how I get A prime. Look again, number 1 here gives me A prime here. Got it? Okay, good. And if you go under the image, under this graph, here are the directions. Translate triangle ABC so that A goes to A prime. First, select the vector tool. Look at the icon. You can find the vector tool right here. Click that. It says vector. Okay, I selected it. Let me see what happens. Oh, it draws vectors. Remember, a vector has one endpoint, only one endpoint. So the other is a direction. A vector shows magnitude and direction. Okay, next, number 2, click on the original point A and then the new point A prime. You should see a vector. Let's do it. So I'm clicking on A and dragging to A prime, and that makes a vector. This vector is going to be used for my translation. Step number 3, select the Translate by Vector tool. Right here, it says Translate by Vector. I'll click it. Step number 4, click on the figure to translate and then click on the vector. Okay, got it? Click on the figure first, then click exactly on the vector. Make sure you don't see a pointer, not an arrow, I'm sorry, but a finger. When you see a finger, then you can click on the vector. Wow, look what happened. An image came. It shows me the image. The original figure is the blue figure. Let me type that in. The original figure is the blue figure. And the green figure is the image. The image shows a shape after a movement, after a rotation, reflection, or translation. We call that the image. Okay, let's notice a few more things. I want you to notice B prime, A prime, and C prime. On the original image, this is point B. Oh, I'm sorry, not on the original image. On the original figure, this is point B. And on the image, the translated image, we call it B prime. Those are corresponding points. Same with C and C prime. Good job, guys. Let's go down to number 2. And number 2 says, translate ABC so that C goes to C prime. But wait, I have A prime. I don't see C prime. Well, that's why I wanted to make sure that you see the slider down here. So go to number 2 on the slider, and then you get C prime. Let's read the directions. Oh, there aren't any directions on this one. You have to remember what to do. Do you remember? Click the vector tool because we're going to need it for a translation. Click on C and drag to C prime. Then go to Translate by Vector. Click the shape and click the vector to get your translation. Good job, you did it. Let's go to number 3. It says rotate ABC 90 degrees counterclockwise using center O. And I want to click the slider to number 3 so that I can see center O. Now I've already read these directions down here. Number 1 says select the rotate around point tool. Select the rotate around point tool. That's right here. We already have the point. The point is O. So we just select the tool, rotate around a point, and then click the figure and click the O, and a box comes up. It says rotate around a point. I can type in whatever I want for the angles. I'm going to say I'm going to rotate 140 degrees clockwise. Okay, let's try it. Bam, and my image is up here. Now you can try and you will rotate ABC 90 degrees counterclockwise. Step 4, reflect triangle ABC using line L. Here's line L. It's already drawn for you as long as you have the slider on number 4. Read the directions. Select the Reflect About Line tool. Click on the figure to reflect, and then click on the line of reflection. Okay, got it? So select the Reflect About Line tool. Click on the figure, and then click on the line. Make sure that your cursor turns into a pointing finger. Bing! Okay, we have reflected along the line. Good job, guys. The next directions say, rotate quadrilateral ABCD 60 degrees counterclockwise using center B. Well, where is center B? It's here. It's the point on the original figure. So that is going to be your rotation point. Do you remember what to do? Click Rotate Around a Point. Click on the figure and then click on the point. The dialog box appears asking you how many degrees. It is 60 degrees and it says counterclockwise. So make sure that counterclockwise is checked and click OK. Now you can see the rotation. Keep going. Read the directions. Rotate quadrilateral ABCD 60 degrees clockwise. I'll let you try on your own, so I save some time on my video. The directions here say to reflect quadrilateral ABCD using line L. Okay, I need to get my line L. I'm on number 7. There, line L. Okay, do you remember how to do a reflection? Click on Reflect About a Line. Then click the shape, then the line. Ding! You got it. That shows a reflection across the line. Please notice that I'm going to draw on here. The points from D to the line is the same distance as the line to D prime. So these points stay the same distance to the line of reflection. I want to draw like that. Okay, that'll help you kind of visualize what's going on with a reflection. Next, the directions say translate quadrilateral ABCD so that A goes to C. Do you remember how to do that? You need to first draw a ray from A to C. Then click on the Translate by Vector tool. Click the shape, then the vector. Looks like I've done something wrong because it didn't move. I'll hit reset. Okay, let's try that again. I need a vector from A to C, and then click Translate by Vector, click the shape and the vector. I need to try again. I must have clicked something wrong. Okay, I'm going to reset. Reset. Try one more time. A to C, translate by vector, click the shape, and now right there. Good, I got it that time. You have to click exactly right. There's my translation. Notice that all of the lengths stay the same. From the original figure to the image, all of the lengths are the same. I'm going to just draw right here, and I'm going to count how many triangles. 1, 2, 3. And on the shape, the image, 1, 2, 3. You can see that the lengths stay the same, And now look at the angle. Here's an angle and here's an angle. How do you know that those angles stayed the same? Look at the grid. Remember that each one of these triangle points is a 60-degree angle? You can see that the angles have stayed the same. Okay, this looks like I have no directions. Oh no, what do I do? Are there no directions for this one? There are directions. It's underneath. Make your own polygon to transform and choose a transformation. Predict what will happen when you transform the image. Try it, were you right? Challenge your friend. Right-click on any vectors or lines and uncheck Show Object. Can they guess what transformation you used? Well, if you're doing remote learning, you might not be able to ask your friend unless you're doing like a share your screen. Let's go ahead and just do this part here. Make your own polygon to transform. Okay, to make a polygon, you can choose points, lines, segments, polygon. Let's choose polygon. So I'm just going to draw points however I want to make the polygon that I dream of. And my polygon looks a little complicated because I didn't get enough sleep last night. There we go. Okay, now I'm going to perform a transformation and see if it moves the way I predict. To do a transformation, I need a vector. A vector looks like a ray. Click on the vector, and then where do I want to move it? I want to move it here. Now this time I'm not even lining up a point on my polygon. I just went from somewhere in the middle of the polygon to somewhere over here. In fact, I'm even gonna, can I move that? Nope, I can't move it because I am still clicking on the vector. Take that one away. Okay, now do you remember what to do a translation by vector? Click the button, translate by vector. Click your polygon, click your vector. Bing, there it goes. All done. Okay guys, I'm going to stop this video and let you get to work. Good luck with that. Bye-bye.